Hello, hello everyone. This is Haiding Tian. In this video, we are learning Chapter 4.1, Graph of Sine and Cosine Function. So in previous lessons, we have learned to use the unit circle to find the value of sine and cosine. And unit circle, they are not a graph of the sine and cosine. For example, if I have a unit circle, and I can use it to help me to find the special value of sine and cosine. For example, how about I'm looking for the sine 0. So 0 is in radian mode. So the point here is 1, 0. So we have learned this is a sine, this is a cosine. So the sine 0 is 0, and the cosine 0 is 1, and you can find the tangent. That's a ratio between the sine over cosine. And another point, for example, here, this is a pi over 6, 30 degrees. And the point on the unit circle here is square root of 3 over 2, comma 1/2. That means sine pi over 6 equals 1/2, and cosine pi over 6 equals square root of 3 over 2, and you can find the tangent. And these are not the graph of the sine and cosine tangent function. So if I can graph, I can draw a T chart, a horizontal T chart. The first row is the angle's value, and the second row is the function's value, sine x. And I can select the special angle from 0 to 2 pi. That means one full cycle. From one full cycle, when x equals 0, sine equals 0. And when the x equals pi over 6, sine x equals 1/2. So I list all of these special values until 2 pi. Then I can graph it on my xy plane. On this x-axis, x represents the angle. And then the y's value represents the function's value, y equals sine x. So when the x equals 0, y's value or sine 0 equals 0. And then continue to plot the point. And I use a smooth curve connect them. I can find the blue curve. That's one full cycle. And how about the other angles? For example, negative pi over 4. I can find my y's value from the unit circle. And I can also find the other angles sine's value. Then I can make a graph. This is a continuous graph. All the way going to the left and all the way going to the right. And one full cycle is from 0 to 2 pi. You see the shape? Okay, and after 2 pi, and copy the first shape, and copy this blue curve. And I will paste it here. When I'm pasting it here, I'm using different color. I'm having another same graph. And look at the left side. It's the same. If I have one period, one full cycle, I copy paste. I will continue to have this graph, this pattern. All right, if I pull out one full cycle from 0 to 2 pi, so look at this image. From 0 to 2 pi, this is the graph of the sine x. And we have 5 important key points. What are they? The first point is 0, 0. So 0 is the angle, and this 0 is sine 0. And second key point is here, that's the maximum. So I insert pi over 2. Then I'm having y's value sine pi over 2, which is 1. And next key point is pi. X equals pi, y equals 0. Next key point, 3 pi over 2, y equals -1. Next key point is 2 pi, 0. So please pause the video and on your scratch paper, draw this image maybe 2 times. So this is a full cycle from 0 to 2 pi. And between 0 to 2 pi, I can cut it into 4 equal parts. So 4 equal parts. The highest point is 1, lowest point is -1. Then my graph is a curve. Oh, sorry. The curve like this. Okay. Going up, going down, going up. So going up at 1/4 of the full cycle, I meet the maximum. And then going down, I meet 0. And then continue to going down, I meet the minimum, that's -1 at 3/4 of the full cycle. Continue to move on, I hit 0, y equals 0. So draw this image and remind yourself, this is a graph of the sine function. All right, let's move on to see cosine. So if I have a chart here, I list all the angles value from 0 to 2 pi. So these are all the special values we have learned. And then second row, they are the y's value or cosine x. Then I plot the points on the xy plane. So look at this, x represent the angle, y represent the function, cosine x. Then I'm having this graph. We're starting from a peak point because I know the first point I'm inserting 0, this is x value or the angle's value. The output is y's value, cosine 0, and cosine 0 or we shouldn't have a degree. This is a radian mode. So cosine 0 equals 1. So the first point is 0, 1. Second key point is pi over 2, 0. This is the third key point, pi, -1. Next key point, 3 pi over 2, 0, and next key point is 2 pi, 1. So you will see these 5 key points is different from the sine function. Oh, that means that this is my one full cycle starting from this peak and then going down. Meet the minimum, going up. Then going up, stop here. So from peak to peak, this is one full cycle for the cosine function, cosine x. After that, I'm having the peak to peak again. So look at my graph. So going down, all the way going up. So this is another full cycle from here to here. And after that, I'm having the same image. The left side, we do the same thing. So we will know that this is the graph of the cosine function. Let's see, let's pull out one full cycle from the graph. So from 0 to 2 pi, from 0 to 2 pi. The cosine is from peak to peak. And these 5 key points, they are first key points, 0, 1. Second key point is pi over 2, 0. Next key point is minimum pi, -1. Next key point is 3 pi over 2, 0. Next key point is 2 pi, 1. So please pause the video and then practice the cosine function on your graph. So you must have the xy plane, x represent the angle, y represent the y's value, or cosine's value, cosine x. And we have one full cycle from 0 to 2 pi. So divide the 2 pi into 4 equal parts. So these are special values. They are pi over 2, pi, 3 pi over 2. And the graph of the cosine from peak to peak. So first key point is, so the maximum is 1, minimum is -1. From the peak to peak, so it's going down, and then here is the minimum, going up, and go back to the peak, which is the y's value equals 1, x value equals 2 pi. So pause the video and practice this one several times, and remember these 5 key points. Next one, let's see, y equals sine x is an odd function. Oh, that means sine is odd function. If I input negative x, then I have negative sine x. And cosine is an even function. So cosine input negative, then there is no negative. So if we have a function, it's an odd function, it's symmetrical along the origin. And the even function means my function is symmetrical along the y-axis. So for example, my cosine function is like this. So this is one full cycle. I cannot say my cosine is just one cycle. I can continue to graph it. So let's see this graph. Yes. So look at the right side, for example, and look at the left side. You see they're symmetrical along the y-axis. So that means if I input a negative x, for example, I input a negative x, then the positive x, they have the same y's value. All right, if I graph sine x and cosine x in one xy plane, you will see the blue curve is a sine x, the pink curve is cosine x. So what is the domain? If you can see from the graph, what is the domain of the sine and cosine? Domain means all the x value. So domain is all the real number because they are all the way, oh, sorry, it's not good looking, all the way going to the left and going to the right. So they will not stop. So that's all real numbers from negative infinity to infinity. How about the range? Range means all the y's value. So the range means all the y's value. That's we're looking at which point is the highest point on the graph, and that point y's value is the maximum value, and which point is the minimum point, has the lowest or smallest y's value. Okay, you see, oh, this point, this point, this point, these are all the highest point. Their value is 1. So the maximum is 1. How about the minimum? Minimum here, 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 and here. So the range is between -1 and 1, and they are all included in the interval notation. And we all know that. We also know in the unit circle, so cosine theta equals x over r, and sine theta equals y over r. So look at the ratio, x over r, y over r. R is greater than x and y. That means the ratio cannot be greater than or equal to x or y. So that means my ratio must be, so absolute value of this is less than or equal to 1, less than or equal to 1. That means absolute value. That means the sine and cosine, they are bounced between -1 and +1. All right, you can also see it from the graph. No point will be greater than 1. No point is y's value is less than -1. The period of the sine and cosine, they are 2 pi. So after 2 pi, we will have the same cycle. The graph sine x is an odd function, so it's symmetrical respect to the origin. And cosine is the even function, symmetric with respect to the y-axis. So that means you can conclude for the sine, input negative x, then the output is negative sine x. If I have the cosine negative x, then I can ignore the x, and ignore the negative sign. All right, next point, the graph of sine x and cosine x differ by horizontal shift of pi over 2. Okay, let's see the graph. If I have the blue curve, which is the sine x, if I shift this one horizontally to the left pi over 2 unit, I'm getting my pink graph. And if I have my pink graph, pink function, that's the cosine function. If I move to the right pi over 2 unit, I'm getting a blue trig function, which is sine x. So the difference between them is horizontal shift of pi over 2. Let's see how to graph y equals a times sine x, y equals a times cosine x. In front of the sine and cosine, there is a a. Let's do a little bit review. So if I have a function f of x, for example, I know the graph of f of x, for example. This is a graph of f of x. If I have a 2 times f of x, let's do the review of the college algebra. What is the meaning of 2 times f of x? So all the y's value multiplied by 2 will stretch, that means we stretch vertically. So my graph will be like this. So 2 times all the y's value. So all the y stretched. So I'm having a graph like this. And how about this? 1/3, for example, f of x. And let's use different color. That's a shrink all the y's value. So all the y's value multiplied by 1/3. So before we have the original function f of x, now I'm having my function like this. I shrink it to 1/3 time of all the y's value, and the x didn't change. And the sine and cosine, they're the same. We have learned that the function sine of x and the sine is a different notation of the f, and the inside of the parentheses is the input x. So this is sine is a function. In front of the function sine, I'm having an a. That means, oh, maybe I stretch or shrink the y's value. All right, let's see the conclusion. A vertical stretch if the a is greater than 1. For example, a equals 2 sine x. So I stretch 2 times of all of my y's value. And the a, absolute value of a, means amplitude. That's so our maximum and minimum value depends on the absolute value of a. So because you see, for example, if I have a point here, this is the maximum, and this is minimum. This point is maximum and minimum for the original function, f of x. And now if I have the 2 in front of the f of x, that means I increase my y's value. So all the y multiplied by 2. So from this point, for example, this point, then I move up to here. That means my maximum value increased or multiplied by 2. And the minimum value here multiplied by 2 move down to here. So the amplitude, the number in front of the sine and cosine will change the minimum and the maximum. All right, let's see. Vertically shrink if the a is less than 1, for example, 1/2 cosine x. So I shrink all the y's value, compress my graph vertically. So how about why we didn't mention about a? We only talked about the absolute value of a, because if the a is a negative, so my graph will have the reflection along the x-axis. So before we have learned, we have negative 2 f of x. In front of the function y, we have negative. That's a reflection along the x-axis. All right. Let's see the first image. First example, y equals 3 times sine x. Okay, let's identify the transformations. In front of the sine x, we have a 3. What is the transformation? Stretch or shrink all the y's value. That stretch. Y is normal. If we have 3 in front of the y's value, we stretch it. That means all my y's value multiplied by 3, or use 3 times y. So if this question is a multiple choice, you don't need to list the 5 key points like the previous examples. But if this is the question asks you to graph it, you must have the key points and then connect them with smooth curve. So for example, this is multiple choice. I don't need to graph it perfectly. I just identify which one is correct. So first in my mind, I must know what is the graph of sine function. So the sine function from 0 to 2 pi, I know the graph is like this. So maximum is 1, minimum is -1. So divide the from 0 to 2 pi into 4 equal parts. So we're having these key points. This is pi over 2, pi, 3 pi over 2. Then the first key point is 0, 0. And second key point is pi over 2, 1. Next key point. So let me graph it. This is a function of sine of x. It's not very good looking. So if you have time, please graph your sine function on your notebook. So nothing very hard. This is a function sine of x. And how about 3 times sine of x? Okay, I put some information here. All the y multiplied by 3. So I stretch it vertically. So the first point, y is 0. So y times 3 is 0. So keep it here. And second point, y is 1. So 1 times 3 is 3. So the second key point is here. And third key point becomes, so 0, keep the 0. And the next key point, y's value is -1. So it becomes -3 because -1 times -3. Next key point, y is 0 is here. Okay, I stretch it vertically 3 times of my original function, sine x. It's not very good looking. Assume this is a beautiful sine function. All right, if you have the multiple choice, so you can select this. You can select this choice. All right, let's see next example. In front of the y, we have the 1/2. And this is a cosine function. We must have the cosine function in our mind. So what does the cosine function look like? So for example, I use the curve. I use the dash curve to draw the cosine function. From 0 to 2 pi, from peak to peak. So first point is 0, 1. Second point is pi over 2, 0. And then pi, -1. 3 pi over 2, 0, 2 pi, 1. So from peak to peak, you cannot use a solid point because this is the helping function, help us to find what is a cosine function. Then based on this one, we do the transformation. So based on this one, let's see the transformation. In front, we have 1/2. That means we will shrink it vertically. That means all the y times 1/2. So before we have the y equals 1, now the x didn't change because x part changed nothing. So now we have the point here. The y's value becomes 1/2. And now the second key point, y equals 0, 0 times 1/2 is 0. Next key point, -1 times 1/2, that is -1/2 here. And next key point is 0, 0 times 1/2. And next key point is 1, 1 becomes 1/2. Now we can connect them. So you will see my graph is compressed vertically. So it's vertically shrinked. All right, we solved this one. So these questions are all depends on if the question is multiple choice. So if it is not multiple choice, first you can list all the key point of the cosine, for example. Cosine, they are 0, pi over 2, pi, 3 pi over 2. And 2 pi. So like what we have learned in the college algebra. In college algebra, we have a T-chart. Here is X, here is Y, and list all the XY points. And the new XY, do the transformation based on the X, based on the Y, and we have the new key point. And here, we draw our XY's value horizontally. So we can see it clearly. So for the key point of cosine, they are 1, 0, -1, 0, and 1. And by the transformation, we have the new T-chart, new chart. This is X. The second line is Y's value, 1/2 cosine X. And does the X change? No, all the X keep the same. Nothing changed here. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. But the Y becomes 1/2. So change all the Y here. 1/2 times 1, 1/2, 0, 0 times 1/2, 0, -1 times 1/2, -1/2, 0, and 1/2. So I can have this key point. First, I can plot 0, 1/2, 0, 1/2, first point, second point, pi over 2, 0, pi over 2, 0, pi, -1/2, next point, 3 pi over 2, 0, next key point is 2 pi, 1/2. And then use the red curve, connect them. You cannot change the shape of cosine. So make sure you still have the graph like this. So you cannot have a different graph like this. You cannot like this. Or you cannot have a straight line because these are sine cosine function. Let's see the question 3. If I have y equals -1/2 sine x, we have two transformations. We're not only having the vertically stretching or compressing, we still have a reflection along the x-axis. So which one goes first? We have learned in college algebra, if I have this one, for example, for example, I have this. I will start from inside of the parentheses. So I will do this one first, and then move outside, then move outside. So these are the order. Now I can say, oh, do the 1/2 first. So if I have 1/2, that means I compress my graph horizontally. So all the y times 1/2. And second step, work on the negative part. So that's a reflection along the x-axis, all the y times -1. Or you can combine these two because this is multiplication. That means my y times -1/2. And the x change nothing. So first I need to know what is the graph of the sine function. Sine is from 0 to 2 pi, and graph of the function, I shouldn't use a solid line because these are the helping lines, helping curves. So for example, so smooth curve. And now, first I can do the shrink my graph 1 to the 1/2. So this is 1/2. And next step, I need to reflect along the x-axis. So my blue dashed line, I need to flip it along the x-axis. So
sorry, I'm not sure.
I'm sorry. And then so I flip it. So the red curve is the one period of the sine function. Here we only talk about one period of the function. You can continue graph it for more period of the function. But I will note to give you bonus point if you continue to draw it. All right, let's see. Next part, there is a b in front of the x. So let's relate it to the function in the college algebra. If I have a number in front of the x is abnormal. If you have a 2 times x, that means I'm shrink my y's value. All the x multiplied by reciprocal of 2. That means all my x becomes a half of the original value. So that's a horizontally shrink. If I have f of x, f of 1/3 of x. So I'm stretched it horizontally. All the x multiplied by reciprocal of 1/3, that is 3. And for the sine and cosine, we have the same thing. So you see that where does the b come from? Oh, it's inside of the parentheses of the input value of sine, cosine, in front of the x. So, if the b is less than, absolute value of b is less than 1, so we are stretching it horizontally because x is abnormal. And if the b is greater than 1, I will shrink my graph horizontally. So for example, if I have sine 1/2 of the x, okay, in front of the x is 1/2. That means I'm stretching my graph horizontally, all the x multiplied by 2. If the b is negative, that's a reflection along the y-axis. That's what we have learned in college algebra. But we prefer to get rid of the negative sign in front of the x. For example, if I have negative sine negative 2x, so we do not like to graph something that is the reflection across the y-axis. We can use the even or odd function to get rid of the negative sign. We have learned that sine is odd function. Odd function means if I have negative input, I can put a negative sign in front, sine 2x. Now I will talk about our reflection along the x-axis. And if I have a cosine negative 1/3 x, I can get rid of the negative sign by using the odd and even function. Cosine is even, so I can get rid of the negative sign. That's cosine 1/3 x. So save me a lot of time and give me less trouble. All right, let's see the first example. Let's erase this. You can pause the video and go back to see the notes. Let's see the first one. If I have the sine 2x, what is the transformation? Right in front of the x, we have a 2. We're doing the shrink horizontally. And all my x becomes reciprocal of the 2 or multiplied by 1/2. And then we can shrink my graph. If this is multiple choice function, you can graph it immediately because I know the graph of the sine. I can graph the sine function first. So you see, I use these 5 key points a lot. And then based on this one, my shrinked graph should be like this. No pointy top, smooth top. So you see my graph has been shrinked horizontally. But for example, if you need to graph it, what should we do? We need to have the exact point. We can find the point for the sine first. The key point of the sine function, there are 0, pi over 2, pi, 3 pi over 2. And last point is 2 pi. And the y's value, they are 0, 1, 0, -1, 0. And the second chart, that is for the point sine, comma, x, comma, sine 2x. So does the x change? Yes, it is, because here, at least only the changing thing is the x. And does the y change? No, I only have the x changed. So I can copy all the y's value from the previous chart, 0, 1, 0, -1, 0. And how about x? X becomes is 1/2, 0 times 1/2, pi over 2 times 1/2, pi times 1/2. 3 pi over 2 times 1/2, and 2 pi times 1/2. Okay, so the first key point is 0, 0, and second point is this is pi over 4, 1. Third point is pi over 2, 0. Next key point is 3 pi over 4, -1, pi, 0. All right, let's see next example. So number 5, we have a complex expression. Why I have the red -1/2 inside of the parentheses? Did you see that negative? Oh, that means I want to get rid of the negative first and make a easy transformation, because we know that if I have a reflection along the y-axis, we need to reflect it. But if I get rid of the reflection along the y-axis, so my graph will be easier. All right, cosine is even or odd function. Okay, remind yourself, cosine is even. So even means cosine -x equals cosine x. If I have negative sign here, I can get rid of the negative. Then the y, the graph I'm looking for is -1/2 times cosine 1/2 x without the negative sign, because cosine is even. I can take away that negative sign. And how to graph it? So first I need to know what is the transformation. So from inside of the parentheses, then outside of the parentheses. So inside of the parentheses, in front of the x, that's 1/2. That's horizontally stretch. We stretch horizontally. So all the x multiplied by 2 reciprocal of 1/2. And second transformation, we move outside, that is 1/2. So y is normal if you have 1/2. Yes, that is compressed. So all the y's value times 1/2. And the third transformation, we have a negative sign. That's reflection along the x-axis. So all my y multiplied by -1. I can combine these two. That represents all the y times -1/2. All right, we have these transformations and how to graph it. So we can find the key point for the cosine first. I will draw a small chart. We have no space. So on the top, we have x. At the bottom, we have cosine, x. So what does the cosine look like? From peak to peak, from 0 to 2 pi. So this is 0, this is 2 pi, and this is middle. So from peak to peak. So let's graph a helping function cosine. And later we graph our function y. For example, this is a graph of the cosine. And the key point, they are 0, okay, pi over 2, too small, pi, 3 pi over 2, and 2 pi. And what are the y's value for cosine? 1, 0, -1, 0, +1. And let's see, let's draw another t-chart. Not t-chart, another chart for the x and the new function, y equals -1/2 cosine 1/2 x. We get rid of the negative sign from the first step. And then let's see the transformation. Oh, first step, second step. So all of the x times 2. So we enlarge all the x value, all the x times 2. So 0 times 2, 0. Pi over 2 times 2, pi. Pi times 2, 2 pi. 3 pi over 2 times 2 is 3 pi. 2 pi times 2, 4 pi. And now let's see what are the y's value. All the y times negative 1/2. Negative 1/2, 0, positive 1/2, and 0, and negative 1/2, because I use all of them times negative 1/2, multiplied by negative 1/2. So I'm having all of these y's value. All right, if we have these key points, let's plot them on my graph. So 0, negative 1/2. So 0, negative 1/2 here. Second point is pi 0, 1/2. Sorry, 2 pi 1/2. 3 pi 0. And 4 pi negative 1/2. Okay, let's graph it. So do not change the shape. If I'm only looking for one period from 0 to 2 pi, because the period changed. So this is a graph. All right, let's see the period of a sine and cosine function. Okay, you can pause the video and I will erase this part. Get some space. Okay, period of sine and cosine function. Let me see. The sine cosine function, they are all have the period is 2 pi, because from their graph you will see the sine from 0 to 2 pi. This is one full cycle. After that, we have the graph like this. And for the cosine, so it's still from 0 to 2 pi. So after that, I'm having the graph like this. So remember that for sine, cosine, their function are 2 pi. But sometimes you will see, I'm not only having sine and cosine, I'm having a sine bx and then cosine bx. There is a b. And if we have the b, for example, the previous example, there is a b here. It changed the function's period. You will see from the previous example, from 0 to 4 pi. Oh, my period changed to 4 pi. Okay, there is a formula, so we must memorize that. If there is a b in front of the x, the period p equals 2 pi over b. For example, if I have 2 times cosine 4x, and you will see, oh, 4 is the b part, because b is in front of the x. Okay, the period equals 2 pi over b, and 2 pi over 4. So pi over 2, or half pi, is the period of this function. All right, let's see example 6 and 7. For example, the example 6, they gave you a graph. Can you find your function by the given graph? I will see. This is a sine or cosine. Look at the graph. From the peak to peak, this is cosine. So immediately I will put cosine here. And can I say this is cosine x? No, I don't know what is the b, because all the function could be maybe a in front, then times cosine bx. I need to know what is a, what is b, and then I can find my function. And the question says, find the period of the function from the graph. Can you see the period? Yes, from peak to peak, This is one period from 0 to pi. Oh, the period for this graph is pi. And for cosine and sine function, what is the formula for the period? Is 2 pi over b. Okay, from this equation, I don't know the b. Can you find the b? Yes, multiply b by b both sides. B pi equals 2 pi, and then divided by pi both sides. B equals 2. Okay, I found my b. So my function y equals a times cosine 2x. I don't know the a. How to find the a? So we mentioned about this at the maybe couple of minutes ago. So the a, the absolute value of a, that's amplitude. So the maximum and minimum of the function is all depends on the amplitude. For example, if the a is 7, so the maximum, if the a is positive 7, so a is absolute value of 7, absolute value of a is 7. 7 is maximum. Oh, this point is 7. That means my a is 7. And is there any reflection? Reflection means if the a is negative 7. If I have negative 7 cosine 2x. No, this is the cosine function. If there is reflection, I'm having a graph like this. So no reflection. That means I'm having a positive 7 as my amplitude. Amplitudes, the maximum and minimum depends on the amplitude. And minimum point here, y's value is also negative 7. So the a is positive 7. We found it from the graph. First, I see the function is not reflected along the x-axis. So a is positive because it's in front of the function cosine. If there is a negative, so my graph is reflection. Second, I see, oh, maximum is 7. So a is 7. And minimum is negative a, or that's negative 7. So that's the reason I ignored the negative sign. All right, let's see number example 7. I didn't do the conclusion, sorry. So y equals 7 times cosine 2x. So this is a solution. All right, let's see number 7. Find the period of the function from the graph. Then find the function y equals a times sine bx, or y equals a times cosine bx. Okay, from the graph, immediately I can identify the graph is a sine function because all my sine function has a shape like this. And can you find the a and the b? Because the sine could not be just a sine x. It could be a times sine bx. What is the a? What is the b? I can find the b from the period. What is the period from the graph? Oh, from 0 to pi. And next cycle, I have the same shape. Oh, so one full cycle is pi. So I will say, from the graph, I can tell my period is pi. And from the formula, the period of the cosine sine equals 2 pi over b. Okay, solve this. The same method like the previous example, b equals 2. If b equals 2, I'm having a times sine 2x. How to solve the a? So is there any reflection? We have negative sine x. No, we have no reflection in front of the sine, because if I have a reflection, I'm having a graph like this. No reflection, I'm having a positive a. So positive a, let's look at the maximum and minimum. So maximum, this point, the y's value is 7. And minimum here is negative 7. Oh, x must be, a must be 7. So my y equals 7 times sine 2x. All right, we're done for today. If you have any question, please let me know. Have a good one. Bye-bye.